In question 1, I'll be teaching you how to use the law of conservation of linear momentum to solve problems. As usual, when we solve problems, we apply the problem-solving strategy, which starts with problem interpretation, what we call the I for interpretation. So I'll begin by interpreting this problem. We are told that a 5 kilogram trolley moves to the right at 3 meters per second, and it collides head-on with a second trolley of mass 7 kilogram moving at 2 meters per second to the left. On a smooth frictionless surface. Refer to the diagram below. Obviously, we can see that we have some form of collision. So this diagram shows before collision what happens. We have the 5 kilogram object that moves at 3 meters per second. So that means I can say that this here is M1, because I can see that I have two objects that interact with each other that will eventually collide. So that is to say I have a system, because remember we defined a system in our previous lesson to be a group of interacting objects. So I have two objects here that are interacting. And because this object is moving in that direction, it then collides head-on with this second object that has a mass of 7 kilogram. That means I can say this is M2 because it's the second object. And it moves with the velocity of 2 meters per second, and it goes to the left. And there is another important aspect to it. They say they move on a smooth frictionless surface. So this surface here is smooth. There's no friction. Now, that information tells me that we are dealing with a closed system, or what we sometimes call an isolated system. That means that our net external force will be 0. Now, I'm going to choose my direction so that the vectors that are pointing to the right will be positive, and that will mean that vectors that go to the left would be a negative. I will just also put that vectors that go up are positive, even though we're not going to work with the ones that are going up, because I can see my motion is along the x-axis. The question further goes, well, perhaps before I read the question further, is that I can identify this velocity to be v1 initial, this velocity here, because it's the initial velocity of the first object, and this would be v2 initial because it's the velocity of the second object. Now the question continues to say, after collision, the 7 kg trolley moves to the right with 1.5 meters per second. Now here, after collision here, this 7 kilogram object goes in the opposite direction from the direction it was going to. So this means here we have a V2 final to be 1.5. Now I have to also mention that this 2 here has to be a negative 2 meters per second, because it's a vector that goes in the negative direction. Because here now it has changed direction, it's going to the positive direction. The last part of the question says, ignore the effects of rotation. Now, of course, you have to note that as the object moves, the wheels will be rotating here. They say we should ignore those effects. The reason why this statement is being put here is that when we have rotational motion, we have what we call angular momentum, moment of inertia, angular speed or angular velocity. And that is the stuff that is outside of our scope. So they're basically saying that we should not worry about those because you're not going to use them in this specific problem. Now, that is problem interpretation. I've interpreted my problem. I fully understand what is going on in this problem. The second thing that I will do in my problem solving is that I will do the classification of the problem, what we call C for classification. The C basically means that we are going to link this problem that we just read with the theory that we know in physics. Which part of physics is this question testing? So as I'm reading this, in my mind, I'm thinking of the previous lesson that we've been doing, because there's hints of having two objects here, meaning we have a system and these two objects are interacting, and we also know that it's a closed system or an isolated system. So that gives me a hint to say this is a question that requires us to know the knowledge of the law of conservation of linear momentum. Therefore, we are going to use, or I'm thinking the questions will be around that law, because all this information that I'm giving here fits really well with the law of conservation of momentum. Now, and of course, you have to see that here after collision, we don't know the information here. We don't know the final velocity of this object, whether it's going in that direction or it's going in that direction. So it's something that we can, be probably asked to solve. Now I'm done with classification. The next rule that I do would be problem answer. In other words, I'm ready now to answer my problem because I've interpreted and I know, or at least I have an idea of what is going on. Now we're going to answer the question. Now, to answer this question, perhaps I can start first by writing down my information so that I can put it properly in the formula, or it can assist me to solve problems. We said that we are taking the right direction as positive, and we're saying that M1 is going to be 5 kilogram and V1 initial is really going to be 3 meters per second. And we said M2 is 7 kilogram and V2 initial is equals to negative 2 meters per second because it goes to the left. We also have V2 final, which they said is 1.5 meters per second. Now let's answer the questions. Now we're going to A. The first question, 1.1, says to us that state the law of conservation of momentum in words, and that is for 2 marks. So they want us to write this law down. Now this is a free mark because you really have to memorize this from your notes and simply answer the question. We call this type of a question a concept question. It focuses on your understanding of concepts. So the law of conservation of linear momentum says that the total linear momentum of an isolated system remains a constant. Right, so we and this is exactly what we classified this problem to be, because we saw that we have an isolated system because there's no friction. They said we should ignore friction, and therefore it means our total linear momentum in this system would be a constant. Right, we expected that sort of question. Now, to answer this question, they're going to give you 2 marks. It means here you need to spend, maximum 2 minutes on this question. Then we go back to, before we go to the next question, the last rule that we apply here is the N. The N stands for problem navigation. In other words, we're going to look at our answer and see if we have written everything correctly here. We didn't do spelling errors. So it's a quick check to see if our answer is correct. So when we look at this, we can see that everything is correct here. So very important to take time and to check your answer. I mean, 2 minutes is a lot. You can be able to use 2 minutes to do that. Now, we are going to cycle back to answer, meaning we answer the next question. In doing so, we're going to question 2.1, 1.2 that says calculate the velocity of the 5 kilogram trolley immediately after collision. So as I said, that we don't know the final velocity of this object after collision. So they're actually asking us now to find that velocity immediately after collision when these two objects have collided and the other one is going that direction, and we're trying to find in which direction is this one going. Now to do that, we can see that this is an isolated system, and that would mean that our total momentum, our total linear momentum is conserved. This is to say that to find our final velocity of the first object, we are going to say the total linear momentum, which is given by m1 v1 final plus m2 v2 final, which this basically is the total momentum after collision, is the total momentum of the system here. We're saying that momentum should be equal to the total momentum m1 v1 initial plus m2 v2 initial. This momentum here after collision should be the same. The total momentum after collision should be the same as the total momentum before collision. It should be equal to this momentum here, the momentum of this system here. Because it's an isolated system, is conserved. You know, we explained in detail from the previous lesson, lesson 6, right, what that means. Now, at this stage now, we can then substitute the information that we have. We know that m1 is given by 5. So here I'm going to have a 5. And v1 final is what we are looking for actually. So I'm going to write that as v1 final plus m2, we said it's a 7. And v2 final is 1.5. Right? So this is the 1.5 here, the 7, and the 5 that we're looking for that. And we say this total momentum should be equal to the 5, and the initial momentum here we were given as a 3. And we also have a 7 here, and we're multiplying this 7 by the -2 because it's going in the negative direction. Very important to remember that. These are vectors. We have to put those negative in that equation there. Now, from here, this question becomes very, 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 very boring because we're just going to press our calculator and find the V final. Now, to do that, I'm going to pull my calculator and punch the left-hand side, the right-hand side. I'll start with the right-hand side. To say I have here 5 times a 3 plus 7 times a -2. And this gives me 1 from this side. And this side here, I'm going to have the 7 times 1.5, 7 times 1.5. And this actually gives me a 10.5. But we still have here the 5v1 final. Now, if we say 1 minus, now I'm going to take this to this side so that I have 1 minus 10.5. So I'm going to have 1 minus 10.5. And this gives me negative 9.5. And here I still have the 5v1 final. Now, from here, I'm going to divide by a 5 and a 5 so that this side, the 5 cancels, and I'm left with 1 V1 final is equals to. Now here, remember we have a 5 here. If I punch this on a calculator to say negative 9.5 divide by the 5, this gives me a negative 1.9 meters per second. Now this can be interpreted to be V1 final is equals to 1.9 meters per second. Remember, negative in this case would mean to the left. So it means this object actually would go to the left after the collision. Now at this stage, we then, remember we were answering the question, we were on A. We then navigate our answer, meaning we check if this answer makes sense. The first thing that you check is that you written the correct symbol, we are calculating the correct thing, and you've written the number in the SI unit because it's velocity, that's the correct SI unit, and I've attached direction because remember, I'm calculating velocity here. Our question was asking us to calculate velocity, which is a vector quantity. So everything looks okay here. The velocity here doesn't look odd, is a good number, almost 2 meters per second, you know. So it's not a bad number. It could be a correct number for the motion and the numbers that I'm given here. The other thing that we have to check maybe could be the direction to say, does it make sense actually for this object to go to the left? We can look at our diagram again. Yes, it does make sense because if you look at the initial momentum of the first object is actually a big number because you have a 7 times a 2, right, which is like 14, and then here we have 5 times 2, which is a 15. So these two initial momenta are nearly the same, so it's possible that when they collide, this object can rebound and go to the opposite direction, right? It's something that is feasible, it makes sense. Now I'm done with navigation. I'm pretty much confident that my answer makes sense and it could be correct. So it means at that level, you are guaranteed to get the 5 marks. And the 5 marks really, and very important to learn what they mark here so that you can write the important things that they mark. The first thing would be the formula. And also again, just to provide here a tip, this formula you have to memorize it and know it because it's not there in the formula sheet. The other one mark would come from substituting the left hand side and substituting the right hand side. So basically they mark if everything here is correct and if everything is correct. If one of the things here is incorrect, you get a wrong there, and the same is true this side. You know, you'll get also another mark for writing the magnitude and the correct SI unit and also writing the direction. All these would be worth 5 marks. Now I know sometimes a lot of learners will be asking me, why don't they mark the simplification here? Well, that's the reason why I said this question, when you get to this stage, it becomes boring because you do this in maths and you can literally punch this in a calculator. They don't necessarily need to give you a mark for that.